Brought to you by the Asombro Institute for Science Education, with support from the USDA Southwest Climate Hub.
Up in the Air is a two-part lesson that models the Earth's carbon cycle and the processes through which carbon is moved between reservoirs. Activities in Part 1 emphasize the relative sizes of carbon reservoirs, and students identify the processes that move carbon between them. In Part 2, students build a quantitative model of carbon fluxes in the form of a board game and calculate how much carbon accumulates in the atmosphere annually. Prepare for Part 1 by printing out the 5 carbon reservoir task cards, table tents, handouts and sorting it out pages, and sets of chemical cards. Cut the task cards, chemical cards, and table tents and fold the table tents in half to stand up. You'll divide students into 5 groups. Each group will need a ball of yarn, a pair of scissors, a yardstick or ruler, a stopwatch, and 3 beanbags or balls. After you use the slides to introduce the carbon cycle, each group will use the yarn to model the relative size of the 5 carbon reservoirs: the ocean, atmosphere, vegetation, soils, and fossil fuel reserves. If you'd like, you can show the rest of this video to the students to explain the activity instructions. Follow the instructions on side 1 of the task card to measure, cut, and tie the yarn into a circle. Every square centimeter of the circle represents 1 petagram, or 10 to the 15th grams of carbon. Set up your table tent at your reservoir, and then read side 2 of the task card to discover how carbon moves in and out of the reservoir. As a class, you'll model carbon fluxes between reservoirs by moving beanbags between the model reservoirs. Each group needs someone to act as a timer, a catcher, and 1 or 2 throwers or walkers. Side 2 of the task card explains where and when each group will move carbon. Some processes, like photosynthesis, happen quickly, and students will move a beanbag every 10 seconds. Other processes occur over long periods of time, like the formation of fossil fuels, and students will move a beanbag every 90 seconds. If carbon is leaving the reservoir and going to multiple reservoirs, you can assign a timer and thrower to each destination. Timers will watch the stopwatch and let throwers know when to move carbon. Throwers will throw or walk a beanbag to the catcher at the correct reservoir. While doing so, they should say the process they are representing out loud. Catchers should stand with their table tent so throwers know which reservoir they represent. Catchers must pay attention to other students who might be throwing carbon in their direction. Timers should all start their stopwatch at the same time. Allow the game to run for 2 or 3 minutes. After the game, use the slides to review the processes that move carbon between reservoirs. Discuss any you're not familiar with. Work in pairs for the next activity. Each pair will need a sorting it out page and a set of chemical cards. You'll use these to describe the chemical reactions that move carbon between reservoirs. Starting with photosynthesis, identify the reactants or substances that go into the chemical reaction. Then identify the products, or what is created by the chemical reaction. Fill out Table 1 on your worksheet and circle the substance with the carbon atoms in both the reactant and the product. Then label the arrow in the diagram that represents photosynthesis. You can use the slides to go over each reaction as a class. Continue with Part 2 of Up in the Air to build a quantitative model of the carbon cycle.
A detailed teacher's guide and accompanying materials for this and other climate change lessons can be found online at asombro.org/climate. Check regularly for updates, new lessons, and information about teacher workshops.